Hello. For my project, I wanted to do the giant Galapagos Island tortoise. Here is a picture of one. So, introduction. The giant Galapagos tortoise are actually a complex made up of 15 total species, but only 10 of them are living. I think some of them also believe that there are 11, so it kind of goes back and forth between 10 and 11. They're one of only two giant tortoise species left in the world. The other one, I believe, is the Aldabra tortoise. The name Galapagos comes from an early Spanish word for tortoise. So that's how the Galapagos Islands got their name. Every main island in the archipelago is home to its own species of tortoise, as well as 5 of the volcanic islands. One of the main island is also home to 2 species instead of just the one. And every living species is at least endangered. Then this species has 2 distinct shell shapes, the dome and the saddleback, which we will further explain later. So why did I choose this animal? I've always had a love for the Galapagos Island tortoise since I was young. While they're very much beloved, not much is known about their history. I wanted to look for answers for questions that I had. What are my questions? First, I wanted to look into why they are so large, regularly reaching over 500 pounds and over 5 feet long. With most tortoise species, they're going to be at most maybe 12 inches long. There's a few species that get a few feet long, but for the most part, it's just the Aldabra and the giant Galapagos tortoise that reach these amazing sizes. And then I wanted to figure out why there's 2 different shell shapes. And it's not just that. I want to look into which one of them came first and which one of them descended from that first shell shape. Here is the largest tortoise recorded, weighing over 800 pounds. I think his name is Goliath. Hypothesis as to why they grow so large. So there's island dwarfism and gigantism, which is where animals that are normally bigger are smaller and animals that are smaller are normally bigger. So an example of dwarfism is I believe it's the Florida key deer, which is a much smaller version of the white-tailed deer. And then you have I believe it's the Tasmanian freshwater lobster, which is pretty much it's a crayfish that's the size of a lobster, which is insane to see. And then there's also the thought that it's just the simple lack of predator pressure that can lead animals to just consume and consume, leaving them to grow and grow and grow. So what I found, giant size is a common trend in other tortoises historically throughout the world. They found giant tortoises in pretty much all continents and countries. The ancestors of the Galapagos tortoise were already giant before they left the mainland. So pretty much what this means is that the giant Galapagos tortoises, one, had their size before they made it to the islands, and that they were simply the only species of giant tortoise that survived. So why did these tortoises survive to modern day? And why is giant size a trend? Sadly, not much is really known for either question. The study that I looked at was not conclusive. It is thought that the Galapagos tortoise survived due to their hardiness. They were reported to float for over 400 miles, and they're able to go over a year without food or water. That is also one of the factors that led to their decreased numbers, as they were preyed upon by early pirates and settlers because they could live on the boats for a long period of time without any care. And then here we have the dome-shaped tortoise on the left, and then the saddleback tortoise on the right. So if you look closely, you will see that the saddleback is much more narrow and has a very high rise at the front of the carapace. So, hypothesis for why saddlebacks have a different shell shape. The high rise in the front of the shell allows them to reach food higher off the ground. The shell shape allows them to fight better for both resources and mates. And lastly, one of the studies I found hypothesized that the shell is shaped that way so that when they get stuck on their back, it's easier for them to self-right. What did I find? First, I found that the saddleback shells actually made the tortoise spend more energy self-righting than the dome shape. So that hypothesis was not proven. Next, I found that it is fairly common for saddleback species to be combative with one another. Lastly, I found that the saddleback shells are only seen in islands that are lower in elevation and arid, where food is more scarce. So they're going to need that upper rise so that they can reach the food that's higher off the ground. What does this mean? The shell shape of the saddleback tortoise was most likely developed for feeding. While it helps in combat, it probably was not the reason for the development of the high rise. In conclusion, I was able to learn a lot about one of the most unique animals in the world. I wasn't able to answer my first question, but I did learn more about the species while trying to find the answer. I was able to learn the purpose of the saddleback shell and where it came from. Thank you for watching. I hope you enjoyed it.